Hi guys, we noticed in class when we were doing the activity about the squares on Wednesday that the opposite sides of those squares had the same slope. And one thing we know about squares is that their opposite sides are parallel. We can take any equations of two lines and determine if those lines are parallel or not by looking at the slopes of the line. Here we have two lines with the slope of -1/2. That would tell us that they're parallel, and if we graph those two lines, you can see that lines with slopes of -1/2 are never going to intersect. The same slope makes them parallel lines. If we wanted to determine if two lines from their equations are parallel or not, without graphing the lines, what we would want to do is put them into our slope-intercept form and determine if those two lines are parallel or not. So you can see here the first line is is already in slope-intercept form. Let's go ahead and put the second line into slope-intercept form and determine if it's parallel to the first line. So slope-intercept form is that y equals mx plus b. I'm going to solve for y here. Gives me -3y equals -2x plus 9, and dividing each term through by -3, I get the equation y equals negative divided by negative would be +2/3 x minus 3. And my question is not what the graph looks like, but whether or not these two lines are parallel. And I can see the first line has a slope of 2/3. Second line also has a slope of 2/3. So to this question, are they parallel or not parallel? I would say yes, they are parallel. We have a symbol for parallel in mathematics. It looks like this. So I could say yes, those are two parallel lines based on the fact that they both have a slope of 2/3. We also want to talk about the idea of perpendicular lines. We know that on that square activity, the two corners of the square, or the two lines that make up the corner of the square, would be perpendicular lines, making that 90-degree angle. And what we know about perpendicular lines is that their slopes are both opposite and reciprocal. Opposite, when I say opposite, we mean that their signs are opposite. So one will be positive and one will be negative. And by reciprocal, we mean the inverse of the fraction. So we flip that fraction over. If I gave you a line of y equals 2/3 x minus 2 and wanted to draw a line that was perpendicular to that, I would know that my new line would have to have a slope of negative, because I need the opposite sign, 3/2 x. And I could use any y-intercept here, maybe -3/2 x minus 1. Here's the equation of the first line, the y equals 2/3 x minus 2, and that just looks like a line through the y-intercept of -2 with a slope of 2/3. But now that I've drawn the other line with the negative reciprocal slope, the opposite reciprocal slope, through the y-intercept of -1, and now I've drawn that second line with the y-intercept of -1, but it has a slope of the opposite sign, and the reciprocal, so it became -3/2, and you can see that's at a right angle to the first line. Perpendicular lines are lines that form right angles. They meet at a 90-degree angle or at a right corner, and their slopes are opposite and reciprocal. They have to be both of those things for us to determine if two lines are perpendicular to each other. Here are two lines, and I want to determine if they are perpendicular to each other or parallel to each other, or neither one of those. Lines don't have to be either parallel or perpendicular. Let me put the second equation into our y equals mx plus b format. So I'm going to subtract x from both sides. 3y equals -x plus 6, and dividing by the 3, I get y equals, and that's -1/3 x plus 2. And all I need to do is inspect the slopes here. Here are two slopes, and I ask myself, are they the same slope? They're clearly not the same, so the two lines are not parallel. Are they opposite signs of each other? Yes, they are. One's positive, one's negative. Are they reciprocals of each other? And I can see that they are if I remember that that whole number slope has a 1 in the denominator. So these two lines have opposite slopes, opposite signs, and they are reciprocals of each other. I would say they are perpendicular to each other. Here are two lines I wanted to determine if they are parallel, perpendicular, or neither. They do not have to be, Here are two lines I want to determine if they are parallel, or our symbol for perpendicular, or nah, they're neither parallel nor perpendicular. Again, I want to put them both into y equals mx plus b format. In this case, I would do that by, in the first equation, subtracting the 2x from both sides. I get y equals minus 2x plus 5 and y equals minus 2x plus 3. Because their slopes are the same, these two lines would be considered parallel lines. If I solve each one of these for y and put it in slope-intercept form, this would become y equals negative x plus 7, subtracting the x from both sides. In this case, the second case, I would add the 3x to both sides. Y equals 3x plus 5. And the question again is, are these parallel, perpendicular, or nah? And because their slopes are not the same, and they're not opposite reciprocals of each other, the answer to this would be they are not parallel, not perpendicular. They are neither. Or, if you want, you can say nah. Okay, so that's a review of parallel and perpendicular lines. Your homework will be to do the other side of the worksheet that we started in class, and we'll see you on Friday.